We're actually going to have our startup showcase. In this, we reached out to the community and invited new startups in the AI space to submit to pitch and participate in this showcase. We reviewed all the finals as a committee, and we came up with 5 here today. Please help me welcome John, who will moderate this discussion.
Is this thing working? Can you hear me? Awesome. All right, guys. Thank you so much for the introduction, Courtney. I know it's a bit late in the day, so we're going to keep this interesting and very exciting. So it's a real honor to be here today hosting the, I think, first ever startup showcase for AI conference. So thanks for having me and for letting me help to organize this. As Courtney mentioned, my name is John Melas-Kyriazi. I am an early stage technology investor with Spark Capital here in San Francisco. So I think most of you in the audience are technologists. And I can tell you that as an investor, it is even harder to keep track of what's going on in AI than as technologists. The first reason is because we're not as smart as you. And the second reason is that the breadth of innovation is absolutely staggering in AI right now, as I think you'll see from this startup panel that we've prepared. So over the past 5 years at Spark in particular, we've seen an explosion in companies that are leveraging machine learning and artificial intelligence to build new products and experiences. You can see a couple of them on the slide here. Just to note 1 or 2, Cruise Automation is a self-driving car company that was acquired by General Motors last year for a little bit more than $1 billion. Sift Science is a fraud detection company that uses a machine learning engine and a proprietary data set that grows with every new customer that they bring on board. And we're looking for more. So if you have interesting startup ideas, please come talk to me after this. So for AI, at least what we've seen at Spark is that there's never been a time when big companies, academia, and startups are all so focused and working so closely together as right now. And that's part of the reason why events like this are amazing, because they bring all of these different stakeholders together to collaborate. The goal for this startup showcase is to introduce you to 5 innovative companies spanning from medical science to chemicals to statistics platforms that are either building applications using machine learning and artificial intelligence or enabling others to do so. And they are solving real business problems, either trying to create new markets that have never existed before or disrupting legacy industries with new technology. All right. So without further ado, I would like to introduce the companies. So please come up when I introduce you. I think that our first speaker is running a couple of minutes late, so we're going to save him for the end. So first up, let's see, Bryce Meredig, founder and chief science officer of Citrine. So I actually first met Bryce when he was a PhD student at Northwestern, and I was trying to figure out graduate school. He ended up having a very successful PhD. I did not. He helps to run a company called Citrine, which is an artificial intelligence platform for materials and chemicals. And I will let Bryce take it away.
All right, thanks, John. There we go. Thank you, yes. So I'm, again, Bryce Meredig, co-founder of Citrine Informatics. Citrine is product development propellant for advanced manufacturing companies. And we do that by enabling these companies to do data-driven materials development. That's so important because it turns out that getting materials right is very often the slowest, most painful bottleneck in getting new products to market faster. And because Citrine is able to deliver that benefit to these companies, we're in commercial use today in the materials and chemical industry itself, which is sort of obvious, but also in a variety of neighboring industries where materials are core to product performance. This would include areas like aerospace, automotive, and consumer electronics. So Citrine was born out of conversations, all 3 of the founders are material scientists by background, conversations that we had with over 100 people across manufacturing broadly. And the question we focused on with them is, how is manufacturing changing? What does the 21st century look like for your industry? And some surprisingly consistent themes emerged in these conversations. And in particular, the number one thing I would highlight is these folks told us in the past, we were evaluated based on the strength of our current product portfolio, the products we have in the market today. And going forward, increasingly, the bar is becoming how quickly can we get new groundbreaking products to market. So speed is becoming critical to manufacturing companies. And we found at Citrine to deliver that speed by specifically focusing on the materials aspects of manufacturing and reducing or eliminating the headaches and the slowness that are, that's traditionally associated with materials. Now, of course, there are barriers on the path to data nirvana in materials and manufacturing. And in particular, materials are sort of painfully analog in a digital world. And I think we heard about that in previous talks, industries that are lagging behind in terms of their use of data. So I can give you a couple of examples of what I mean by that. So one is if you look at the aerospace industry, and you look at how do materials engineers at Boeing or Airbus find materials data that's relevant to them and analyze it for making product-oriented decisions. It turns out that very often what they do is they go to their corporate library and pull down physical handbooks that contain parameters and find charts with design allowables and sort of try to eyeball these parameters for different materials that they use in their designs. So of course there's a lot of room for digitization there. Another example would be we talked to a Fortune 500 manufacturing company. We said, can you tell us about how you communicate the performance of your materials to your customers? And they said, well, the materials engineer that developed the new product opens Microsoft Word, types in the materials performance parameters for their new product. They export it as a PDF file. They email the PDF file to our webmaster who puts it on our website, and customers go to that website and download these PDFs in bulk from us and other manufacturers and type in the values and the parameters in these PDF files into Excel spreadsheets that they keep at their site. That's actually how a lot of these industries work today. And also we've talked, of course, to people on the other side, the customers of these companies, and they've said this is an extremely painful way to consume materials data. So these industries are crying out for better data infrastructure and a solution that brings order to the chaos of data silos, unstructured data formats, and many different data formats that exist inside these companies. What we find is that companies that use our platform start to think differently about their data, and they start to think of data around materials and chemicals that they generate as a proprietary, extremely valuable corporate asset. So historically, these companies, if they, let's say, conducted 10,000 trials to get to a certain level of product performance that they're looking for, they would say, we have 9,999 failures and 1 success. And they focus on that 1 success. That's sort of the traditional Thomas Edison approach to product development. You try things until they work, and then you commercialize the thing that worked. Citrine turns this sort of thinking on its head. We say, you don't have 9,999 failures, you have 10,000 data points that you can use from this point forward forever in all your future product development to inform how you design your products and how you design materials into your products. So our platform is enabling these companies to use data in a way that they didn't think was possible before. So again, historically, the way product development, materials development works is a very traditional scientific method of hypothesize, test, and iterate. Now, of course, Citrine, the goal of our platform is to dramatically reduce the number of cycles that these companies have to go through. But another challenge that these companies have is that these cycles tend to be strongly intuition-driven. And what I mean by that is if a company is trying to develop a new chemical compound, what they would typically do is go to the person, the physical chemist who's been doing this for 30 years and say, come up with a new product. Now this person's really smart and really good at what they do, but they are also human, meaning they are subject to human limitations. And in particular, there are biases in their development that hinder the kinds of products they can come up with. And in particular, what they tend to focus on are things that work well and things that they've learned recently. And of course, as many people here will know, if we have a large data resource and machine learning layered on top of it, suddenly we can harness thousands, tens of thousands, hundreds of thousands of previous results from across the company and outside the company to dramatically expand the palette of solutions that product designer or chemist has available to them. So I want to conclude by summarizing sort of the three key pillars of Citrine's platform. Number one is the data ingestion engine that, again, brings order to the chaos of materials and chemical and product data inside these advanced manufacturing companies. We take the analog data and we make it digital. Then, of course, there's the related idea of data infrastructure, and this is the idea that all the things these companies have learned throughout their histories and the things that they're learning in real time today should be available to everyone inside the enterprise as they need it all the time, and they should have the data-driven tools that enable them to actually garner insights from those very large data sets. And then finally, of course, is the predictive artificial intelligence tools that we deliver on top of the platform that enables these companies to substantially focus and de-risk their materials development that's going along with their product development. And what we found is that our customers have very consistently been able to achieve R&D targets in 2 to 5x less time by using these tools. So with that, I'll conclude. Thank you so much for your attention, and I'd be glad to take questions. Yeah, sure. So the question is about how do we, well, basically, what does it look like to apply machine learning to physics and chemistry? There's obviously a lot there that I could talk about, so I'll focus on one thing in particular, which is that materials obey the laws of nature, the laws of physics and chemistry. And what that means is anytime we know chemistry going into a problem, if there's an equation or some kind of law or rule that describes what we should see, we always want to use that as a constraint or sort of as signal for machine learning rather than throwing the baby out with the bathwater. That's so important because very often the areas that we operate in are data starved. Generating data is extremely expensive in R&D. It's slow and it takes a lot of expensive people's time to do it. So by using these known physical principles and baking those into our machine learning framework, which we've done, it enables our customers to get away with using a lot less data. So it's both. It's both simulation and what they're doing in the laboratory. So we have customers that, of course, very commonly do both. They're running physics-based simulations. They're doing tests in the laboratory. We harness all that data at the same time. Say if they're doing solar materials development, that's what one of our customers was doing. We took advantage explicitly both of scientific simulations and experimental data from their laboratory to help them, in this case, design a new solar material. Okay, I hope I understood that question right. So higher order interactions are critical to the problems that customers use our platform to solve. A good example of that would be formulations. So formulations would be what people in the paint industry or even cosmetics do, where they might mix together 10 or 15 different compounds, solvents, and polymers and so forth in their final product. Even that expert, that physical chemist who has 30 years of experience has a lot of trouble figuring out how are these 2 different solvents and these 3 different copolymers going to interact when I mix them together in this new formulation. So that's a case actually where our tools become even more powerful relative to a human operating on their own because we do a pretty good job of mapping out those higher order interactions. Okay, thank you very much.
Good to see you, man. All right, thank you so much, Bryce. I forgot to mention this before, but let's save questions for the end after all the startups have presented, and then we can do a bunch of Q&A. Next up is Will Murphy, co-founder and VP of Business Development at Tala. Tala gives you the power to turn your chat platform into a command center for your company. Tala enables business processes in chat, such as onboarding employees, training on new skills, polling, and building out custom experiences. Prior to Tala, Will was an innovation executive at FedEx and founded a number of venture-backed startups.
All right. Good afternoon, everyone. So, yeah, as he mentioned, I'm Will from Tala, and we call it a service assistant. It's a combination of using what you know of as a service desk, which is kind of like a help desk where you create tickets. You kind of customers kind of understand that model, and combining it with a digital intelligent agent, so it's a service agent. And so we think this is kind of the beginning of, let's see if I can, yes. So there's three parts to Tala: the conversational knowledge base, the conversational tracking system, and intelligent workflows. And as you'll see, kind of this is what we think is the beginning of kind of creating an intelligent agent that helps you do your work inside your company. So every employee has tasks that they do that fall into these two categories, right? All of your employees have exciting work that they're doing, and then have monotonous work that they're doing, and kind of day to day you're kind of going up and down inside of this type of graph. Well, Tala wants to take over the monotonous work so humans can focus more on the exciting work that they're interested in. So why is now the right time to combine artificial intelligence and chat and creating a chat bot? One is the future of work. We believe the future of work revolves around chat, and we believe that AI and machine learning are making software smarter. So let's talk about that for a moment. The future of work revolves around chat. We have all these interesting new types of chat platforms that are popping up. Slack is a good example. All of these we will support at one point. We support Slack and Microsoft Teams now. We also have integrations with HipChat. We're working with Google on getting inside of their Google Hangouts chat. Now, these are new types of platforms. We've had chat around for years. The types of platforms these are is they allow you to create your own kind of channels where your team can break off into specific topics. And they also allow an interesting thing where they have these APIs where they allow a bot to be a user. So we're using that. We're combining it with AI. So this is something I started sketching out before Tala, actually. And I feel like we're going through these waves. Every 5 years, we've kind of had these interesting waves that have been happening, starting with really the browser in 1995 being built on top of the internet. And every 5 years, we've had kind of Web 2.0 come around 2000. We've had social wave come, and all of these waves build on top of each other. They don't disappear. Then you had the collaborative wave, which is like these collaborative commerce companies like Uber. And now we're starting the intelligent automation wave. So you can combine chat with AI, and you can start kind of this process of building this assistant that lives inside your company, and you can create a conversational service desk. Now, what is interesting about Tala is we talked earlier about what is your proprietary information that you're collecting that makes your startup interesting. Ours is all of the data that's in your employees' heads. So you have systems of records for all kinds of data inside your company. The data that we're interested in collecting via conversation, which is, the humans' our own way of communicating information to each other. We want to collect that information and have that intel, and that's our proprietary information. So we're starting, we don't do audio type chat yet, we just do chat within Slack and these chat platforms. But the interesting thing is a lot of business communications is starting to happen over these, right? If you're talking about a large percentage of internal communications in a lot of companies is moving from email. I don't think it'll totally replace email. but a lot of the internal communications is moving from email to chat. So that's pretty interesting. So why would you need this kind of solution? Well, let's look at the scenario that happens today. Somebody has a question about, do they have Columbus Day off? So they may ask the person next to them, they may look on their calendar, they may search the wiki, then they look around and find somebody to email, then they maybe send an email, and then they wait for an answer. So we want to kind of jump in the middle of this situation and improve it. So this creates all these problems of employees not knowing where to go. Maybe they do go to a wiki or something that's outdated and that information is not useful, then they search around for somebody to talk to answer that. Also, it's time consuming. This causes time consuming problems for humans where even the person they're interrupting, it's taking time out of their day as well. So you have cost in time and efficiency. You have cost in money as well. And so the way we're starting this is this three-pronged approach where we have a conversational knowledge base. And I'm going to step through it really quickly, kind of show you what it looks like within Slack. So the conversational knowledge base is very simple. You ask a question and you get an answer. So you ask a question, Tala provides an answer. Then you can give a rating on whether you like the answer or not, or whether that was helpful. That actually feeds back into our system to improve Tala in the future. You have intelligent workflows, which you can think of as question and answer being, request response. An intelligent workflow, the way we use it is, it's a predetermined conversation that the employee is having with the bot. So the employee may ask a question that then triggers a multi-step conversation back and forth between the bot and the employee. To help them, it could be a checklist. We support all types of things like polls and checklists, things like that can pop up inside of a workflow. And then a conversational ticketing system. So this third piece, the conversational ticketing system, you may ask Tala a question that Tala does not know, which then sends a ticket that is created inside of a web interface that an employee totally understands as a kind of a help desk type ticketing system that they've seen before. We also give recommended answers. So it creates tickets that people it can go to the right person. We're working on the information, we're working on the capability to know who to ask, like who's the expert that should be answering this question. They can come in and then they will have, if Tala knows some some things that it looks like that could be true, Tala can then recommend answers that the human can select. And those of you that are a little bit more technical, and we talked about human in the loop before, this is our, from the business side, perspective on taking a human-in-the-loop web interface and putting it into our product. So we don't have an employee on our side that's human-in-the-loop, that's running the human-in-the-loop. We're putting this at our customer side. So this is a help desk. It's a help desk, but it's also a human-in-the-loop trainer for our AI. So then the answer is then provided back to our system that then Tala goes and follows up back with the correct answer, but then also that information is training Tala to take on more and more of these answers the next time it sees a similar question. So as you can see, this is kind of Tala in action. You have the conversational knowledge base and the intelligent workflows, all kind of centering around this conversational tracking system that's run by human. Thank you.
Thank you very much, Will. Next, we have Scott Clark, co-founder and CEO of CoOp. CoOp is a SaaS optimization platform that amplifies your research. Scott holds a PhD in applied math from Cornell and previously worked as a software engineer at Yelp. Thanks for coming on. Yeah.
Good afternoon, everybody. Thanks for having me. Today I'm going to talk to you about a very common but often overlooked problem in machine learning and AI. And I'm going to tell you how CoOp can help you solve that. So what we do is we take a machine learning or AI platform that's already in place, And we look at all the different configurable parameters that define how it actually goes about doing its learning. So you can think about the learning rates, the stochastic gradient descent parameters, the architectures of these neural networks you've been hearing about today. And we help fine-tune these configurations, getting you better results, faster and cheaper than standard methods. So I'm going to take a step back for a second and explain why this is a big problem. First up, every single machine learning algorithm has these tunable parameters, whether you're aware of it or not. So the simplest random forest makes you select the number of trees. The most sophisticated deep learning platform may have several dozen potential parameters. 1 second. All right, sweet. God, this remote's great. Excellent. So this might be common for some of you guys. This was a fun platform that Google released about a year ago. It's playground.tensorflow.org. What it does is it lets you train a neural network in your browser. And this is really fun because you can actually kind of see what's going on underneath the hood a little bit. It's doing a relatively simple problem here of just 2D binary classification. We've got orange dots, we've got blue dots. We want to come up with some surface that's orange where it's orange, blue where it's blue, etc. But when this came out, I couldn't think of a more obvious reason for a tool like SIGOPT, because hidden in this page is 22 different tunable knobs and levers that you have to set before you end up training this neural network. So imagine you're working at a bank and you have to perform fraud detection. So you may be an expert in understanding that data, understanding the context of where it's being applied. Maybe you're building up cool different features that you're going to be feeding into your machine learning algorithm. But then before you actually press go and have it go train on your big cluster, you need to be able to decide learning rates, activation functions, architectures, etc. And often this is an extremely trial and error-based process that requires a lot of expert time and a lot of computational resources to solve. So SIGOPT solves this automatically by providing this simple API that wraps around your machine learning algorithms. And this matters because often you're not actually playing with graphical interfaces when you're coming up with these different algorithms in your day-to-day work. You're looking at code. You may be deciding you're going to use MXNet or something like that. And buried in all of these algorithms are these magic numbers. Does this have a laser on it? Sweet. So we have things like learning rates, gamma parameters, epsilons for how accurate we actually care about this being at the end of the day. And it's often very difficult to build intuition around how we set these specific parameters. But it can have a huge effect on the bottom line. So traditionally, the way that people solve this and the way that a lot of open source algorithms tell you to go about tackling this problem is via things like manually searching for different configurations, exhaustively searching over with something like a grid search, randomly searching for configurations. These are all very suboptimal ways to do optimization and waste a lot of time and computational resources because it can be extremely time-consuming and expensive every time you want to try something new. So SIGOPT, once again, replaces this with our ensemble of state-of-the-art Bayesian optimization algorithms. We tell you configurations to evaluate. You tell us how well they did. We learn from that to decide the next most intelligent configuration to try and repeat, driving you to better results exponentially faster than that brute force grid search, orders of magnitude faster than the random search approach, but also kind of alleviating the need for you to do 10-dimensional trial and error optimization in your head. And at the end of the day, this can lead to huge performance gains. So this was some recent work that we did with Google, where we took an MXNet convolutional neural network doing a natural language processing task, and we were able to boost its performance by just tuning these tunable hyperparameters, which means it's additive with any of the work that you're doing as a data scientist or machine learning engineer. Additionally, one of the reasons why this hasn't been kind of widely accepted within the field is it's been very difficult to get these systems up and running. I saw this, and it was the main user feedback I got after I wrote the metric optimization engine at Yelp, which tries to tackle this from a more open source perspective. So we designed SIGOPT to be 2 lines of code in Python, R, Java, MATLAB, examples with all the different deep learning libraries you've heard about today. The goal is you focus on what you're great at, we'll bolt on top and provide you this best-in-class optimization. We publish at all the top machine learning conferences. We're pulling in experts from around the world to help build this automatic ensemble. We're adding features that make this easier, simpler to use, can bolt on top of really any underlying system. And at the end of the day, your data and your model lives with you, and we just sit on top and help you configure it. We're already in production use with customers around the world, helping them tune everything from algorithmic trading strategies to deep learning frameworks in fraud, insurance, oil and gas. And at the end of the day, we'd love to help you tune your models as well. So if you ever waste any time doing hyperparameter configuration, or if you're doing something like a grid search today, we'd love to talk to you. Thank you.
Thank you, Scott. Next up, we have Shiva Amiri, CEO of Biometrics. Biometrics is transforming the science of big data analytics and machine learning for complex biomedical data types through its pre-processing and analytics platform called Augusta. Shiva holds a PhD in computational biochemistry from Oxford University, and previously was an executive at a computational drug discovery company and a big data analytics company.
Thank you. Thanks very much. Can you all hear me? I'm mic'd. Yes. Great. First of all, thank you to Courtney and our team for having us here. This has been a great conference, and we love the venue. So I'll get started. We are called Biometrics. I've been with the company for over 2 years now, and we want to talk about the future of medical data science. Thank you. Yeah, if you're going to advance it, that's fine. So there's a lot going on about precision medicine. Precision medicine, there's a lot of promise. There's a lot of pitfalls. What's the promise? The promise is that we're going to have better drugs. We're going to have preventative mechanisms. We can have better healthcare. We can lower costs because we have a better understanding of each individual. And we can think, there's so much data out there these days. We have the technology. There's still a lot to do in the biomedical side. There's still a lot of disorders we haven't figured out. There's still a lot of drugs we haven't figured out. So there's still a huge opportunity. So this is the promise of precision medicine. But what are the challenges? The challenges is that there's a lot of types of data out there. It's really difficult, actually, to analyze it effectively. There's a lack of standards. This is a huge problem, and this is what, actually, the CoOps guys have picked up on, and this is what we've noticed, that it is a massive challenge in making sure you have valuable analytics, machine learning, and AI from your biomedical data. Lack of scalability. A lot of the companies that come to us, they have a lot of data. It continues to build, but they don't know how to manage that. They don't know how to organize it, combine it effectively, which are the right types of data to use, and how do you ask the right questions? What are the technologies you need to use to get your answers? Can we go to the next one? Thank you. Market opportunity. I'm not going to spend a lot of time here. It's a huge market, and it's building. So we have wearables now. We have health. A lot of different types of streaming data in health. We have building repositories of images, genomics, tons of data coming together. So all of this is compounding the different types of data and the market, the different use cases with pharmaceutical companies, diagnostic companies. There's a spectrum of companies and organizations that are producing data and very interested in getting answers from those data types. So what have we built? So the slide's gone again, but what we have built is a way to enable companies and organizations to optimize in the different types of biomedical data that they have. For example, we combine genetics data with imaging data, with clinical data, with drug data, because genetics alone has not paid off in a lot of ways. There's a lot of exciting things like CRISPR-Cas9 coming out. You heard there's 20 trials starting this year and next year. Imaging is good for certain types of diagnosis, not all. So for precision medicine, there's a lot of value in being able to combine the different types of data. Yeah, that's the slide, the competitive advantage. So this is what we do. We do integrated, combined analytics. The other thing we do that sets us apart is kind of what the SecOps team is doing. We customize the pre-processing and the models based on the data, because we learned, and we know this is true, there's a lot of literature on this. If you try to replicate results for imaging alone, let's just take the imaging example, it's very difficult because there's different parameters that were used. The data is coming from different machines and different sites. It's you cannot rely on these results. So what you have to do is go back and pay a lot of attention to what happens to the data upstream. You have to go back and parameterize accurately. You have to think about the features you're feeding into your machine learning algorithms. So this is what we spend a lot of time doing. We have a lot of internal expertise on how to do this. And we've spent the past 2 years developing these pipelines. We've had traction from companies both on the pharmaceutical side of the spectrum to the diagnostic side. Actually, we have a microbiome project with Harvard Medical School, which is an example that was given before. So there's a lot of different types of medicine and health that are looking at combining different types of data that's out there. And why not use all of it? Why just focus on the genetics? I mean, there's a lot of good that can come of that as well. But we feel that for precision medicine, we need to take a look at various types of data. Can we go next, please? Yeah. So this is just an example of some of our pipelines that you can use by themselves or in combination. So there's a lot of work to do before you even get to the machine learning and AI stage. And then there's the post-analysis and visualization that comes after. So this is our product. It's called Augusta. And what we do is we take in your raw data and we help you make sense of it for a variety of questions in precision medicine, whether it's therapeutics or diagnostics. If we go next, I want to give a couple of examples of what happens when you actually combine data types. So this is an example. We analyzed over 1,000 autism subjects. Some were normal, some were autistic. And what we did is we combined genetic data with fMRIs and MRIs. So you can see we've identified some variants or genes that could be implicated in autism. And then you can relate that back to the fMRI and MRI images of those patients to see, is there anatomical differences? You can do that the other way around as well. You can look at the anatomical differences and then look at the genetic variants to see which of those subjects have a different set of variants, for example. Can we go to the next slide? Oh, there we go. Oh. Yeah, great. Thank you. So this one we think is really compelling. It's an Alzheimer's example. We looked at about 400 Alzheimer's patients, and we realized if you look at the MRI images alone, with random forest and LSVM, the graph on the left-hand side, you get a certain amount of accuracy. If you look at the genetics alone for Alzheimer's, you don't get a lot of accuracy. It's not a good you can't really diagnose Alzheimer's based on your genes yet, from what we know. But if you combine MRI plus genetics, you get an increased accuracy and precision of your models, which is significant. On the right-hand side, we noticed if you add on the metabolomic data, so stuff in your blood, you get an average of 5% increase on the improvement in accuracy of your models for most of the questions you may want to ask. This is not universal, but this is generally the effect that we're seeing. So we have good evidence that combining different types of data helps you answer questions more effectively. But you have to do it properly. You have to spend a lot of time parameterizing, and this is part of our proprietary capability, is how we actually optimize the features before the machine learning step happens. We have an excellent team. This is our management team in Toronto. They have backgrounds in signal processing and genetics and machine learning. And they couldn't be here today, but they were really excited about this event. And thank you very much for your time.
Thank you so much, Shiva. Thank you for being so gracious about the technical issues. Last but not least, we have Chris Nicholson, founder and CEO of Skymind. So Skymind is the company behind Deep Learning 4J. the only commercial grade, open source, distributed deep learning library written for Java and Scala. Before Skymind, Chris was a reporter and ran communications and recruiting for Future Advisor, a fintech startup that was acquired by BlackRock.
Thanks, John.
Thanks. Cheers.
Hi, everybody. I'm going to test these. There we go. There we go. And I'm going to riff a bit, and then I'll come back to the slides for a bit. So I'll give you the headlines about Skymind. We're a 3-year-old company. We have 25 people, 3/4 of whom are deep learning engineers and systems engineers. Like John said, we built deep learning for J. J is for Java. Java is the world's largest programming language. And we're one of the top 5 deep learning tools in the world, right? You've all heard of TensorFlow. You've probably heard of Caffe and Keras. We dominate the JVM. So sitting next to those wonderful tools for the Python ecosystem. And you can think of us as the bridge from Python to the JVM production environment, which is obviously a place where a lot of enterprise has concentrated their investments, especially in that big data stack. So I'd actually like, if I can see you through the spotlights, I'd like to take a quick survey, and then I'm going to tell a personal story. So how many of you work daily on it and technically with deep learning and machine learning? How many of you are technical people building AI solutions? Okay, great. How many of you are on the business side? Okay, great. Of the technical people, how many of you are data scientists? Would you say? Okay. How about data engineers? No data engineers at all. Oh, a couple. Got it. Okay, it's good to know. One last question. Startups? Who's in a startup? Okay. How many people are working for a Borg, a large corporation? Okay, great. Good to know. So I'll tell you, now's the time for a personal story. 4 years ago, I came to Silicon Valley from Paris, France. I have a checkered past. I used to be a journalist, and I apologize for that. And I went out of the frying pan and into the fire when I went into PR here in Silicon Valley with Future Advisor. But at the same time, I moved into a hacker house in Soma, a startup hostel, right? A reservoir of spare beds for people who can't find an apartment in the crazy real estate market of San Francisco. And in the room next to me, with 5 other snoring guys, was a fellow named Adam Gibson. He's my technical co-founder, and he's the person who created deep learning for J. Now, he created it with our team of 20 engineers, but in the beginning it was just him. He was building. And why was he building it? And why was he building it in late 2013? The answer is because Google, which is the top AI company in the world, had just hired Jeff Hinton, the top researcher in deep learning. They hadn't announced TensorFlow yet, but what they had announced with that hire was that deep learning had business applications. And the question that Adam started asking himself was, what are the open source tools that I can use for the big data stack in enterprise to bring those deep learning solutions to companies, to the Fortune 2000, and create value for them? And the answer was the tools didn't exist at the time, right? So scratching his own itch, he began to create deep learning for J. And deep learning for J, if you're a software developer, you know there's rabbit holes within rabbit holes. Deep learning for J led many other places. Where did it lead? It led to us creating ND for J, n-dimensional arrays for Java. That's basically NumPy for the JVM, a tensor or a matrix library. It led to us creating an ETL tool for data pre-processing. So all these stages of the deep learning workflow had to be built for the JVM to be able to build AI solutions and produce results, which are just the analytics, right? Just the scores that you get from inference. Those scores are hard to produce, even if you have functioning tools. So the problem that Scott is solving with CoOp is a very hard and very important problem, a massive search problem to find the right combination of hyperparameters. In any case, I met Adam. It was the 2 of us, one maker and one bullshitter. And we started building this thing. He was writing the code. I was documenting it. I could just barely read what he was writing. And we slowly grew. Tencent came in as the early money. We went through Y Combinator. We raised the seed round last year, and we finally grew to this spot where we had a dozen enterprise clients, telecoms, banks, retailers, healthcare, aviation. And these clients are all part of the same kind of almost secular historical shift from big data, the big data stack. They can gather and store and move data all day, to the AI stack, right? And the AI stack is that culmination. It's the addition of the final layer that tells them what they've got, right? That one last layer. It's the filter on the pipe that flags something when it comes through, right? If you're sending an image through the pipe, it says that's Chris's face or that's Scott's face, right? If you're sending a transaction through the pipe, it might say, oh, that's fraud coming through, or that's a normal transaction, right? And what we face in the world now are a ton of companies that know they want AI, but they don't know how to build it, right? CoOp solves part of that problem. A lot of vertical specific companies like Biometrics solve part of that problem. And the part of the problem that we solve is a little bit lower, right? It's a general purpose AI platform. It's a horizontal company where we're coming in and bringing them a toolkit, right? And we're bringing them a team of field engineers, forward deployed people like Palantir has or like Cloudera has, right? And the way you can think of us is we're Cloudera for deep learning. So those forward deployed engineers go in there and they build AI solutions for the companies who can't yet or they don't have time yet, right? We're doing it with our open source software, Deep Learning for J. We're bundling that into an enterprise distribution. So if you know the enterprise software space, you know RHEL, Red Hat Enterprise Linux, you know CDH, right? Cloudera's distribution of Hadoop. Well, we've got something like that too. We think we called it Skill because we thought we were clever. It means the Skymind intelligence layer, and that bundles all our open source stuff together in versions that work, a rare thing in software, that we deploy to our customers. So that's our business model. That's kind of how we work. I've got about a minute left, and I would actually like to open this up for questions. Does anybody have any questions for me? Yes, yes you do. There we go. The most exciting what? Yeah. Great question. So deep learning is machine perception, right? You're getting raw sensory data and you're giving it meaning. You're building classifiers and clusters and predictive analytics. So, you know, you can name a photo or you can cluster transactions if they're anomalous. But what's even more interesting is combining deep learning with other algorithms, like we see with AlphaGo, right? Where you have a moment of machine perception, where the algorithm recognizes the state of the world, and then it goes one step further in intelligence and says, here's what I think you should do, right? To achieve what you think you want. Right, so those combinations of algorithms are actually the most exciting things, and we've built reinforcement learning, and we're combining it with deep learning, right? And in the future, I think we'll all see even more amazing things than just winning at board games. Yeah. Any other questions? Yeah. How do I see them using deep learning and what? Some of them are. Okay, so the AI market is shaped like a pyramid, right? At the apex, you have companies like Google, Facebook, Amazon, Microsoft. They rolled their own deep learning frameworks, right? Tier 2, and these are still A-list companies, Apple, eBay, right? But they haven't built their own deep learning frameworks. They are building solutions with other people's tools, and we're supporting them, right? Tier 3 would be the big data stack companies, the Hadoop market, right? $20 billion, right? There's a lot of them, and those are folks who have in-housed the skill to handle big data, but they still don't know how to build machine learning and deep learning solutions yet. That's where a field team like ours comes in handy. Right? And then finally, at the bottom of that pyramid, you have companies that have outsourced how they handle big data. Maybe they're relying on SAP or something like that. And those are the people where all we can give them is advice and a roadmap and say, here's what we think you should do if you orient your software procurement around the open source stack, Hadoop and Spark, to get to the place where AI can be useful to you. Yeah. So that's my time. Thank you, everybody.
All right, thank you, Chris. So Courtney, I think we're a few minutes over. Do we have time for some Q&A, or should we move on to the next thing? Sorry, so we'll do some Q&A? Great. Can I invite all of the startup participants to come up on stage for a couple minutes? All right, the floor is yours. What questions do you have? Yes.
So for Shiva, one of the slides that you were showing, a lot of it I understood just to be you had prior knowledge already because it's focusing specifically on pharma. But then you had one slide saying that your actual algorithms were better than, I forget the list of them, but you know, it was like our revolution, et cetera, et cetera. I was curious, is it algorithmic stuff that you're focusing on, or is it more just similar to CoOp that you can work with better initial
We do the initial parameter optimization through this mechanism that we've developed. And then we optimize on the features that go into the machine learning algorithm. And then sometimes we use machine learning algorithms that are openly available. But we also have a core machine learning software that has no limit on the number of rows, for example. So we benchmark that against R and H2O and some others. And so that's but yeah, we do both. Yeah.
Yes.
Question for Tala. How did you solve the text accuracy and the noise in the text? I'm assuming when when you're filtering a lot of child text, there's a lot of noise and there's like a lot of people that is not inaccurate. How do you solve that?
That's a great question. We tried that at first. So we've got a couple ways to approach this. One is kind of narrowing the scope of kind of what can be said. The other thing is what I call a hybrid interface. So we started as pure text, our company did, and we shifted more towards using the chat platforms, buttons, and those sorts of things. So the design principle that we use now is what I call a hybrid interface design. It's use the most efficient communication method with the human to be for the specific circumstance that you're communicating. So we started all text, and we got into that situation where we were retraining the model a lot. We were, finding the percentage of issues and kind of making those changes on an ongoing basis. But then we tested, just using buttons in some circumstances, and we found that the customer was just as happy. So it was like, why build a tractor when a bicycle will get them across the neighborhood or whatever. So the design principle I call this is the hybrid interface. And so right now we do really a combination of things where the interface within the chat platform is a lot more constrained now. And so what we'll do is we do have some kind of wide open text, and what we do there is have the capability to create combinations of like for the same question, and then we match the nearest. But what we do is we may have several different, maybe 10 different examples of the same question, and then try to do matching on that. And then, like I said, the cool thing about conversational interfaces is you can ask follow-up questions. So if we don't find an answer, if we don't find exactly the right response to what the human asked, what we can do is we can ask a follow-up question and ask, like, is one of these things kind of what you were asking, which then creates a loop. So the cool thing about it is kind of combining AI with very well-designed conversations where you can do follow-up questions, makes it a lot more interesting and intelligent over time. You can think of like when you do a Google search, you search and you get back 1 million responses, and it's like, we've ranked them, but good luck. Within a conversational interface, the intelligent agent can come back and say, well, I think maybe you're asking me one of these 3 things. And if you tell me which one, then I'm going to give you the answer, but then that's going to feed back into my training. So it's kind of a combination of really smart workflows on how we're communicating back with the employee, and also kind of constraining as much as possible. If it really doesn't matter, and often it really doesn't, if there's a button capability like Slack, all of these chat platforms are getting intelligent where their design is good, where they're adding buttons and those kind of things. And we'll use those rich design elements if it helps the interaction. We don't go all the way over and try to do everything via text. So.
Thank you. All the way in the back.
Great question. So for those of you in this part of the room that might not have heard that, where does CoOp actually come into the stack? Is it at the very end, or can it be used during the development process as well? Well, we see good value for our customers in kind of both contexts. It could be something where maybe they have a fraud detection algorithm in place that's been there for 10 years. Maybe somebody manually tuned it once, but that optima might have drifted over time or something like that. And we can come in and just kind of immediately retune it to get you to a peak performance. Other times we find companies that are like, okay, I want to start doing deep learning. So I'm going to download Skymind, I'm going to download TensorFlow, I'm going to download something like that, but I'm immediately faced with this problem of how do I configure it? How many layers do I set? What are my learning rates? And a lot of times the open source kind of leaves you wanting more in terms of some guidance on this. They tell you just trial and error, just figure it out. So we can actually help accelerate, I guess, that flywheel of development by getting you to that peak performance, saving you time from needing to do it yourself, letting you invest more time into your domain expertise, and kind of spin up these models and get them to their peak a lot faster. So it can work in both contexts, but for the fastest, like immediate business ROI, it's usually bolting it on top of something that's already in production and providing a boost.
All the way in the back with the red shirt.
Can you say that one more time? I'm sorry. Yeah, great question. So are the end optimized parameters dependent on the data? Yes, and especially in deep learning. You can take an identical architecture that was designed to do some specific, maybe classification task. So for our TensorFlow example, we were looking at classifying images of digits. Using just the standard like zip code data set. And then we use this Google Street View data set, which is also just images of digits. And one performed extremely well because it was hand-tuned to look good for their examples. And using the exact same data, very similar data set, it got really terrible results. By retuning the architecture, by retuning the hyperparameters, we were able to get it up well above kind of standard baseline performance of something like a random forest, where it had kind of fallen flat before. So the data matters, the output that you care about matters, finding these optimal hyperparameter configurations can be a very difficult problem, and that's part of why we exist, is because it's this tedious thing that just perpetually keeps coming up, and we want to automate that away. Great question, though. Thank you.
Any other last questions? All right. Give one big round of applause for our participants.